This video is about equivalent fractions. Basically, equivalent fractions are fractions that look different, but actually equal the same thing. Let's see an example. 2/4 is equivalent to 1/2. This is just a random example that I came up with, but it illustrates a point. Specifically, the numbers on the top and bottom of each fraction share the same ratio as the numbers on the top and bottom of the other fraction. Remember, fractions are ratios, so if the ratio is the same, then that means the fractions themselves must be equivalent. If you're confused by the terminology, let me see if I can explain it better by drawing a picture. This is a visual representation of the fact that 2/4 is equivalent to 1/2. It means that whenever I see 2/4, I'm free to replace it with 1/2 if I want to, because they're equal to each other. In fact, there are infinitely many other fractions which are also equivalent to 1/2. Like these, for example. 3/6, 4/8, or even 8/16 would all mean the same thing. Do you see why? You can keep cutting the whole into as many pieces as you want, but as long as you keep the same proportion, also known as the same ratio, right, then the fraction is going to remain equivalent. Okay, now I want to point something out. These diagrams are great for understanding what equivalent fractions are, but you really don't want to have to draw this out each time you come across them, right? Fortunately, you don't have to. Much in the same way as other topics that involve fractions, there's a bit of a shortcut rule that you can use to do it quickly. I'll illustrate with another example. Suppose we wanted to determine if 4/5 was the same as 8/12. An easy way to do this is to simply see if you can find some number that, if you multiplied both the top and bottom of one fraction by it, you would be able to make the other fraction. So, for example, if I multiply the top and bottom of 4/5 by 2, I'll end up with 8/10, because 4 times 2 is 8, and 5 times 2 is 10. Now, clearly, 8/10 is not the same as 8/12. So I therefore know that these fractions cannot be equivalent. I mean, I could try it with a different number too. I could go 4 times 3 is 12, and 5 times 3 is 15. That's still not going to work. There's nothing I can do, there's no number that I can multiply the top and bottom of 4/5 by that's going to make it turn into an 8/12. That's how I know that the fractions are not equivalent. Let's take a look at another example though. Let's say we are comparing 3/4 and 9/12. You see how it's possible to multiply the top and bottom of 3/4 by the same number, in this case 3, so that it will look the same as the other fraction? 3 times 3 is 9, and 4 times 3 is 12. So these fractions are equivalent, and the fact that we are able to multiply the top and bottom of one fraction by the same number to turn it into the other is how we know for sure. As a side note, and maybe some of you noticed this, isn't multiplying the top and bottom by the same number really just the same as multiplying the entire fraction by 1? Because anything over itself is 1, and 1 times anything is itself? Don't worry if you didn't get that last part, because you'll probably figure it out once yourself, once you start doing these type of problems. In any case, we're almost finished with this video, but I just wanted to talk about one more thing that is basically just like another way of looking at this. I want to show you how you can, given some fraction, create as many equivalent fractions as you want. So check it out. If you were trying to multiply some number that was going to be the same for the top and bottom of 7/10, you could pick any number you want as long as you stayed consistent. So let's say, for example, that I picked a 5. 7 times 5 is 35, and 10 times 5 is 50. So, therefore, I know that 35 over 50 is a fraction which is equivalent to 7/10. Or, I could even multiply by 100. 7 times 100 is 700, and 10 times 100 is 1000. So, therefore, 7/10 is the same as 700 over 1000. And it works in reverse, too. If I then divided top and bottom by 100, I would get right back to 7/10. Are you starting to get the idea? Equivalent fractions are pretty useful, and once you get the hang of it, they're quite simple to work with. Just remember, always do the same thing to the top of the fraction as you do to the bottom.